Good morning, children. Hope you understood Archimedes' principle clearly from the previous video, as I did the practical part of it also. But in theory, you don't have to study. Okay, this will be only for practicals. You can just write for practicals, and you don't have to study this for theory. Okay, so all this is for practical, and then this part we'll be doing in part C. This is part of part C. Okay, so A part is over actually with this. Okay, so um, not chapter 6, I'm sorry, this is in part C. Okay, I thought it's the next chapter, but then I realized it's a C part. Okay, flotation is C part of the same chapter. Okay, so few portions of this will be done in part C, and then rest all are over. And then numericals, again I told you, again 3 questions will be done in the next part. Otherwise, this part is over. Now we go to relative density and its measurement by Archimedes' principle. Okay, and that is also cut. The whole part is cut. Okay, so happily you can strike off the whole portion, and we'll go straight to C part. Okay, so we'll have to go straight to C part. Okay, flotation. So you all know what is flotation. A body can either float or sink in a liquid depending on its density. So this you have studied in lower classes also. Whenever density of solid is greater than density of liquid, the body will sink. The body will sink. And whenever density of liquid or whenever density of solid is less than density of liquid, the body will float. So this example may be a stone. If you put inside water, it's going to sink because its density is more than water. On the other hand, if I put a wooden cork, okay, wooden cork, then it will keep floating because its density is less than the density of water. So it will keep floating. Now these are the conclusions that you have studied so far. Okay, now we are going to see little more in detail about flotation. Okay, now whenever a body is submerged in water, okay, it's kept inside or submerged in water, you know, two forces are going to act. Okay, so they are showing a body which is partially floating. Partially floating means part of it is outside, part of it is inside. This is also possible. So when a body is floating or when it is inside water, you know, two forces are acting. One is the weight that is acting in the downward direction. The other one is upthrust that is acting in the upward direction. Weight that is acting in the downward direction. The other one is the upthrust that is acting in the upward direction. Now, you all know this. Weight will be acting from a point called center of gravity, CG. Or even they will write C. They just write G. Sorry, center of gravity is G. And buoyant force will act from a point called center of buoyancy. Okay, it will act from a point. Actually, it should be overlapping this. Okay, and this point is called center of buoyancy. So, weight will act from center of gravity. Weight will act from center of gravity, and upthrust will act from center of buoyancy. Now, what is center? Center of gravity, you all know, right? It is the point where the entire weight of the body acts. The entire weight of the body seems to act from this point. That point is called center of gravity. Now, center of buoyancy means that is the center of gravity of the displaced liquid. You know that whenever you put a solid inside, it will displace some liquid. Now the displaced liquid's center of gravity is called center of buoyancy. Okay, so this is the first thing you have to know. Okay, weight W of a body acts vertically downward through the center of gravity of the body. Second force, upthrust Fb of the liquid acting vertically upwards through the center of buoyancy. So this is the definition of center of buoyancy, that is the center of gravity of the displaced liquid. Center of gravity of the displaced liquid. So the upthrust is equal in magnitude to the weight of the liquid displaced. This force has a tendency to make the body float. Okay, so this is the first thing you should know, that there are two forces acting: weight in downward direction, upthrust in upward direction. Weight acts from center of gravity. Okay, usually we write it only G, and upthrust acts from center of buoyancy. Usually center of gravity, buoyancy will be below center of gravity. Okay, now this is the general case. Now we are going to have three cases. We are going to have three cases based on the weight of the body and upthrust. Okay. Now case 1. In case 1, we are taking W greater than FB. Okay, and all the three cases will have three different diagrams. Keep that in mind. Okay, W greater than FB. In this case, what will happen? The body will sink. Okay, in this case, the body will sink fully. Okay, it will be fully inside water. So your diagram will, in your diagram you have to show like this body will be completely inside water, and weight, now weight and buoyancy, weight and upthrust both will act from the same point. Center of gravity and center of buoyancy both will be the same points. Okay, both will be the same point here. So weight, both will act from the same point. Okay. Okay, and in this case, apparent weight of the body. Okay, these are the conclusions. Okay, body will sink. Second conclusion, the apparent weight of the body. Apparent weight means weight in the liquid. Okay, so this body will have an apparent weight. Okay, that will be weight in air, that is W minus upthrust. Okay, W minus upthrust will give you the apparent weight of this body, that is its weight inside liquid. And the third conclusion, in this case is possible when only when density of solid is greater than density of liquid. Density of solid is greater than density of liquid. Is it clear, children? So these three conclusion plus the diagram. Okay, so case 1 we have considered, if W is greater than upthrust, then the body will sink fully. Okay, and in that case, both W and upthrust will be acting from point. W will act from G, upthrust will act from B, but both the points will be same. And then the body will have an apparent weight which is equal to W minus FB. Then in this case, density of solid will be greater than density of liquid. Now, case 2. Okay, let's underline first. So case 1. Okay, when W greater than FB dash. He has used one dash, but it's upthrust basically. Okay, in this case, body will sink. So that's the first conclusion. Second one, apparent weight of the body, that is weight of the body inside liquid as measured by a spring balance, if it is attached with the body, will be W minus FB dash acting vertically downwards. Acting vertically downwards. So if I measure with a spring balance, it will give me the apparent weight. The third one, this is the case when density of solid is greater than density of liquid, when rho S is greater than rho L. And the fourth one is the diagram. Let's go to case 2 now. case 2, W equal to FB. W equal to FB. Now, in this case, the body will float, but its entire part will be inside water. The body will float with its entire part. You're able to see this? This is sinking. It has come down. This is floating, but its entire part is inside water. So this is what will happen when weight and upthrust are equal. Okay. So again, B and G, the same points. Weight will be acting from here. FB will act from here. And W will be equal to FB. Okay, so this case, body will float with its entire body inside water, inside the liquid. Okay, so inside water or inside liquid. So it will float with entire body inside liquid. Second one, what will be the apparent weight of the body in this case? It will be 0. Why? Apparent weight is basically what? Weight in air minus upthrust, and here both are equal, so apparent will be 0. When a body is going to float in like this with its entire body inside water, you put a spring balance here and see its weight, it will be showing 0. Okay, if a body is floating with its entire thing just inside water, its weight will be 0. So apparent weight will be 0. And third one, in this case, density of solid will be equal to density of liquid. Density of solid, the solid will be equal to density of liquid. That's when it floats like this. And then the fourth one is the diagram. Hope you all have got it, children. So second case, we are taking weight is equal to upthrust. So in this case, it will float with its entire body inside water. And then its apparent weight will be 0. Because weight and upthrust are equal. This minus apparent weight is W minus FB. Because they are equal, apparent weight will be 0. And this is the case where density of solid will be equal to density of liquid. Then case 3. Now before that, we'll mark it quickly. Case 2. First one, body will float just below the surface of liquid. Not water. It can be any liquid. Okay. Surface of liquid. Second conclusion, apparent weight of the body will be 0. Apparent weight will be 0. Third conclusion, density of a body is equal to density of liquid, or density of solid will be equal to density of liquid. And the fourth point is the diagram. Okay. Then come to the third case, case 3. Case 3, when W is less than FB. In this case, W greater than FB. Case 1, then W equal to FB. Then case 3, W less than FB. Now, in this case, what will happen? This is the actual floating. So, body will float with part of its body inside water and part of its body outside water. Part of its body will be inside water and part of its body will be outside water. Okay. So what will be your conclusion? Float with part of body inside liquid and part of body outside liquid. Inside liquid. In this case also apparent weight will be 0. Okay, when it is floating like this, if I put a spring balance here, it will be showing 0. Third one, this is the case when density of solid is less than density of liquid. Density of solid is less than density of liquid. Now let's come to the diagram, which is what is very important. The diagram, as usual, W will be acting from here, that is G, and this is buoyancy, and upthrust will act from here. Upthrust will act from here. Okay, so this is like normal, the normal case. Okay, now the point you should know is the how much volume will submerge inside water. How much volume will be inside water? How much volume will be outside water? Now, the rule is, the principle is, it will submerge. See, some way apparent weight has to be 0. For apparent weight to be 0, what should be the case? The weight of the floating body should be equal to upthrust. Weight of the floating body equal to upthrust. So, and according to Archimedes' principle, you know that upthrust is equal to weight of liquid displaced. Weight of liquid displaced. Now, it will submerge to such an extent so that it will displace liquid so that its weight will become equal to the weight of the floating body. Can you understand? Okay. Now, suppose, for example, let's take the weight of this body is 100 gram force, and upthrust is coming to be only weight is 80 gram force and upthrust is 90 gram force. Upthrust is 90 gram force. Okay, so it will float. It will the part which how much volume will be inside water, that is decided by this concept that it will submerge to such an extent so that it can displace water in such a way that it will be equal to the weight of the liquid displaced. Okay, so when I say 90 gram force, that is the upthrust when the whole part is inside water. When the whole part is inside water. Now the whole part will not be inside water. Okay, so part of it has to be outside, part of it has to be inside. Now how much will be inside is decided by the difference between these two. The difference between these two. So it will submerge to such an extent so that the upthrust, now some way weight will be always 80, upthrust also has to be 80. So you don't want the entire part to be submerged, only that much part to be submerged so that its upthrust will be only 80 gram force. Can you understand, children? Because volume of body submerged part is decreased. You know, no, upthrust is equal to volume of solid into density of liquid into G. So by doing like this, only you're allowing few part, lesser part of the solid to submerge inside water. By doing that, upthrust will decrease. So it will submerge to such an extent so that the upthrust will also become equal to the weight, and hence apparent weight will be 0. This is called principle of flotation. This leads us to the main principle called principle of flotation. Principle of flotation. According to the principle of flotation, okay, actually when we say flotation, this is the case we are talking about. This is the case, okay. So it will float to such extent. Okay, according to the principle of flotation, for a floating body, for any floating body, weight of the floating body should be equal to upthrust. Okay, weight of the floating body should be equal to upthrust. Floating body should be equal to upthrust. So that is the principle of flotation. Okay, I think we didn't mark case 3. So come to case 3. Weight is less than upthrust. First point, the body floats partially above and partially below the surface of liquid. And then they have, so this much is enough, but they have given this only that much portion of the body gets submerged, by which weight of displaced liquid becomes equal to the weight of the body. In this situation, weight acts at the center of gravity while upthrust acts at the center of buoyancy, which is vertically below G. And the weight is equal to upthrust only due to the submerged part of the body. Okay, this is about how much portion will be submerged. Then come to the second point. Now I'm just, because you're going to do a comparison of all 3 cases. Okay, so according to that comparison, first part you will write The body floats partially above and partially below the surface of liquid. Second point, apparent weight of the body again will be 0 in this case also. Third point, density of body will be less than density of liquid. Density of solid will be less than density of liquid. So then it leads to the principle of flotation. So this is a statement. State the principle of flotation. Weight of a floating body is equal to the weight of the liquid displaced by its submerged part. Weight of the floating body will be equal to the weight of the liquid displaced by its submerged part. Okay, so that's why they mentioned submerged part. Only part of it will be submerged, and in such a way that the weight of this liquid displaced should be equal to the weight of the floating body. So apparent weight will be 0. So this is the conclusion of these 3 cases. Now, what I want you to do is, after listening to this video, I want you to make a table like this. Okay, this I made it roughly, children. So case 1, case 2, case 3. Okay, make 3 columns. Okay, 3 columns. Case 1, W greater than FB. Case 2, W equal to FB. Case 3, W less than FB. Okay, the first point will be, okay, as I wrote, point 1, 2, 3, 1, 2, 3. Okay, first is body will sink. Body will float with its entire body inside water. Part of the body will be inside liquid. Part of the body will be outside liquid. So second point, apparent weight. It will have an apparent weight. It will not be 0. That will be W minus FB. Here apparent weight will be 0. Here also apparent weight will be 0. Is it clear? And the third point is about density of solid and density of liquid. In this case, density of solid is greater than liquid. You can just use symbols. Okay. So apparent weight will be equal to W minus FB. In this case, apparent weight 0. Apparent weight 0. Okay, in this case, density of solid, okay, you know that is greater than density of liquid, equal, then less. Then the fourth one will be the diagrams. I want you to draw all the 3 diagrams. For case 1, this diagram, case 2 this, and case 3 this diagram. Is it clear? So this I want you to do it in your notebook. Take a fresh page. If you want, you can take a notebook horizontally. Okay, you can tilt your notebook, turn your notebook, keep it horizontally, and then make a table like this and do a comparison. Is it clear? So this will help you to enable you to study clearly. Okay. So, okay, fine. We'll just do one more part. So, weight of the floating body. According to principle of flotation, weight of the floating body should be equal to the weight of the liquid displaced by the submerged part. Okay, after rest, or weight of liquid displaced by the submerged part. Now, from this, I can get one equation like this. So, we are going to derive this equation. Now, weight of the floating body. You know, mass of the floating body. In the numerical we did. Okay. So, let's take solids volume. Okay. This body's volume of the body is Vs, and density of the solid is rho s, and then liquid displaced, not the entire liquid, only the volume of liquid displaced, that is volume of the submerged part. You just don't write like this. Volume of submerged part of the body. is equal to small v. Let's take it as, okay, this will be smaller than this, small v. Let's take the symbol as small. The entire volume of the body, we took it as capital V suffix s. The volume of submerged part, we are taking only small v. And density of liquid will be, density of solid is rho s, and density of liquid is rho L. Okay, these are the symbols that we are going to use. Now, you know that weight of a floating body, weight is m into g. Okay, mass of the floating body into acceleration due to gravity. So this is mass of the body into acceleration due to gravity. And here, weight of liquid displaced by the submerged part of the body, that will be mass of the liquid displaced into acceleration due to gravity. Anyway, G and G will get cut. Now, in terms of, I know volume and density. So what is mass in terms of volume and density? Density is mass upon volume. So mass is density into volume. So mass of the body or mass of solid, I can write volume of solid into density of solid. Instead of mass of the body or solid, I can write volume of solid into density of liquid. Mass of liquid displaced will be volume of submerged part, okay, because it will displace liquid only equal to the submerged part. So V into rho L. For solid, Vs into rho S. For mass of liquid displaced, small v. What is small v? Volume of the submerged part of the body. Okay, so in this diagram, children, this volume is small v and this whole volume is capital V, S. Volume of the whole thing is Vs. The submerged part ka volume is small v. Okay. So now I can get a relationship like this. Vs upon small v is equal to rho L upon rho S. This I am bringing it down to the denominator and this I am taking here to the denominator. So volume of, or the other way I can write, small v upon Vs is equal to density of solid upon density of liquid. So if I have to write it in words, I can write immersed volume upon total volume of the solid. Okay, immersed volume of solid upon total volume of solid is equal to density of solid upon density of liquid. So from principle of flotation, okay, the expression that I can receive is immersed volume upon total volume is equal to density of solid upon density of liquid. So in this diagram, this volume, ratio of this volume upon this volume is equal to density of solid upon density of liquid. Okay, so this is the conclusion from principle of moments. Volume of immersed part upon total volume is equal to density of solid upon density of liquid. So I'm stopping with here. Okay, hope you have understood this clearly. Thank you, children.